All right, guys, so before I forget, next, so tomorrow and Thursday in lab, we'll have a group worksheet. And then Monday and Tuesday next week, we'll have a quiz. Yeah, so next Monday, Tuesday. When's the next test? March 8th. When is March 8th? Next Thursday. What? No quiz tomorrow. Yeah.
Is it this or
Oh,
the
wait.
packet
Yeah.
side?
That's right. Anybody else need one of these packets? Come get out. Let's disseminate those. Yeah. Oh. Oh yeah, keep forgetting to put page numbers on these damn things. Guys, so I want you to do this. This problem number 4, the first number, good old number 4. I decided 1, 2, 3 gets used so much. I want to start at 4. This is actually should be a review of stuff you know already. Let's see if that's true. All right. These should be relatively quick because they're already solved for y, right? Already done that first part. So this first line, so I'm going to number these just to get you guys to maybe consider the fact that that's a good idea in general. I got equation number 1, equation number 2. What's equation number 1's y-intercept? 2. I like it, 0, 2, even better. And then I'm going to go down 1, over 1. Down 1 over. So my suggestion to you, the whole idea, what is the idea? What is it when I graph a line? Why do we graph lines? And you're all like, because you need us to do shit. I don't know. If I ask you, what are the answers to that equation number 1? Can you list the answers to equation number 1? No, you can't. You can give me a few, right? You can give me a few ideas. Y is negative x plus 2. So if x was 1, y would be 1. So 1, 1 is a solution. In fact, we just went through the point 1, 1, didn't we? Stay with me. Are you guys with me? I want you to get this because sometimes we just don't tell you guys this. And graphing is a huge part of mathematics. It's not just because we needed more stuff for you guys to do. It's because what's the best way to answer the question? What are all the answers to that problem? Well, let me plot a few and then connect it and say, there you go. Go find the one you want. I ain't got time for that shit. I'm not going to make a list of all the answers. I'm going to give you a picture of all the answers. So really, when I graph a line, it's a graphical representation of all the answers to the equation. Because there's an infinite number of them. Oh my God. So of course here I got to, let's see what I can do here. So down 1 over 1, down 1 over 1. I'm doing that on purpose. I'm doing several steps. Make the point big. There you go. And what about the other one? So that's equation number 1. What about equation number 2? It's got a y-intercept 0, negative 3. And then I want to go up 2 over 1. And then I want to go up 2, let's see, up 2 over 1. Did they make one that actually works? Up 2 over 1. That looks gross. Good job, everybody over there. All right, I like this. I'm not sure why they did this. All right. So the answer would be where they meet. Now, unfortunately, they don't actually meet, which is really, really a silly example. I appreciate that so much. So let me make a better example. Let's do this. Let's do this one together. Real quick. Hopefully it makes sense. This is kind of a good example for after you get one that works nice. Because this one shows you why we have algebraic ways to solve it. Because can you tell me what the exact answer is? Where do they meet? And why is where they meet the answer? So if one line is all the answers to that equation, and the other line is all the answers to that equation, where is the place where they both work? Where they meet? That's great. Hold on to that. We're not there yet. All right. So what have I had? I'll say 2x minus 3. I like that. That's the same thing. Good. We'll make one that's a little better. What if I had y equals negative x? Yeah. Plus 3. Yeah, that'll work. So they were just off by a little bit. Okay. So I got this is always the most exciting thing. 2x minus 3. I'm just going to kind of do this a little bit quickly. Right? So 2x minus 3, that would be here, up 2 over 1, up 2 over 1. There's that line. Negative x plus 3 is up here, down 1 over 1, down 1 over 1. There you go. So what is the solution to that system of equations? 2, 1, because that's where they meet. So the answer to a system of equations with 2 variables will always be a point with 2 coordinates. Because it's geometrically, it's where they meet. All right. So now this is old news. You guys did this already. You're supposed to have, and that's why you're here. Okay, you guys with me? Because today we're going to get into what the hell does it mean when I have 3 letters in a freaking equation? What does that mean graphically in the real world, geometrically? Right? We're not quite there yet. Okay. In the lab tomorrow, the next day, we'll be talking about how to use the intersect function on the calculator to do this work for us. There's a whee. If you want to try it out on your own. Now, in the lab today, I noticed some people didn't really remember elimination too well or something. So here's a really weird idea. This is the kind of question you should bring up. What am I allowed to do to an equation? What am I allowed to do to an equation? What can I do to that first equation in general? What could I do? Huh? Sure, I could add stuff to both sides, subtract stuff to both sides. I can multiply both sides by everything except 0, right? Because then that would just destroy both sides. I can't do that. And I could divide both sides by everything except 0 again, right? You're all like, yes, Jeff, that's, you've already been doing that shit. So that's why you should have a problem. You should kind of have a problem when I say, let's add those 2 equations together. That should be like, all right, I'll do it, but I don't know why. So you guys, who remembers this elimination method? Anybody remember the elimination method? And you know the process. You know you add them together if there's a letter that's going to disappear. The whole idea is there's too many things I don't know. So let me kill one of them so I can solve for the other one. So now watch. Guys, if I add these sides together, what do I get? 12. That's great. So what did I do? I added 4 to this side. I added 4 to 8, right? I'm supposed to add 4 to the other side. Isn't that the rule for solving equations? Are you with me? If I add 4 to one side, I better freaking add 4 to the other side. But what is 4? 4 is x plus y. So if I add 4 to one side and I add x plus y to the other side, that is completely legal because x plus y is freaking 4. That's why you're allowed to add equations together. You shouldn't just accept that. That should kind of go like, wait a minute, what? I could do that? And yes, you can. It totally makes sense. It's completely allowed. So what happens on this side if I add them together? 2x. And the y's go away. If I ever add them together and something doesn't cancel, I've done something wrong. I haven't made a better equation. Would you guys agree that's a better equation? Why is it better? Because there's only one thing I don't know. Did you have a question? You good? Okay. So then both sides I can divide by 2. Now don't stop there. Because what is the answer supposed to be? Yeah, it's supposed to be a point where they meet. So just stopping at x is no good. So how the hell am I supposed to get y? Yeah, you've got 2 equations that are supposed to be true. I could plug it into either one. So if I pick this one and I put 6 in place of x, you guys see that? I just put 6 where x is, because I know x is 6. I figured that much out. Solve for y, I get 2. So I will accept this as an answer. This is fine, but what's a slightly better way to write the answer? Careful. What? 6 comma negative 2, yeah. X, y. And what's true about that point? That point is where those 2 lines would meet if I did graph them alike. Kick ass. Yes, ma'am.
So is that what we could use to solve the one we did?
Yes, I love it. That's probably what Mark did, or some variation of that. There's a substitution method also, but we're going to focus on the elimination method. You guys might remember the substitution method. I always call that the sneaky method. You go in and replace. It's like Invasion of the Body Snatchers. Replace you with something else. Or not. I don't know. It's up to you. Now what's kind of wrong with the approach we just used for this? If I add those 2 equations together, what doesn't happen that I wanted to have happen? Nothing freaking cancels. So don't do it. I always see people add those together and then they keep going somehow, and I'm like, wait, if nothing cancels, you didn't make a better equation. You did something wrong. So nothing cancels because these are not the same number opposite signs. This one was beautiful. The y's have the same coefficient with opposite signs. They want to die. I let them die. Right? We are a compassionate state. We let them die. That's a little too political. I'll stay away from it. The nice thing is I always think of this as LCD. Like, which ones are already opposite signs? Which letters already have opposite signs? The y's. So 4 and 5, what's the LCD between them? 20. So I'm going to multiply the first one by 5. I'm going to multiply the first equation by 5. So I get what? 15x minus 20y equals negative. Get another one in there. Do you guys understand what's happening? I can multiply both sides of the equation by anything except 0. I can multiply both sides by 38.77771 if I wanted to. I'm not going to do that shit. It's not going to help me. What about number 2? I'm going to multiply the second one by what? 4. So I'm going to get 8x. Oh, I lost an x here. Oops. Plus 20y equals 16 times 4? 64. If you're just coming in, you want to grab a little booklet. Oh, here, Mike. Right on top. Oh, wow. Hello. Let's go over your head, sorry. Sure. Okay. All right. Do you guys see why I feel good about where we are? Bless you. What happens when I add these together? These cancel. So then here I get
23
23x,
46.
negative 46y. Now please, ooh, there it is. Now please realize the answers will not always be pretty. Right? You can get fractions. That does not mean necessarily that you did something wrong. Well, what do I do here to solve this?
Divide by 23.
And thankfully 23
Equal -2.
goes into that evenly. I love it. Yes, it's water from the sky. Come on. Is that a word? Alright. So how am I done? Yeah, plug it back in. Where? It doesn't matter. You use either one, but I agree the bottom one looks a little more friendly. So if I plug in a -2 for x, I can figure out what y is. So I always call this like dominoes. Once you figure something out, it falls back, you can plug it back in. It'll make a little more sense when we have 3 equations with 3 letters in them. Oh shit. So here I get, it's -4, so I add 4, I get 5y equals 20, I divide by 5, I get y equals 4. So the nice thing is you can plug them in to see if it works. You can check it like always. You can plug in -2 and 4 into this equation since we didn't use it and make sure it works. That would be -6 minus 16 is -22. Check. And if you leave your answer like this, I'm okay with that. But what again? What's a slightly better way to write the answer?
-2, 4.
Because that captures the physical idea behind it. That's the point where those lines would meet. I like it. Here, let me give you one to try. Forgot to put some more on it. You guys try this one. Let's see if Jeff can make one that works nice. Oh shit, Jeff. Here we go. This is exciting. All right, let's see if that works. All right, have fun. All right, guys, let's see. You had a choice you could make here. Both of them are already opposite sign. Now, if they're not already opposite signs, you just multiply one of them by a negative. You've got to make them opposite signs, or else they ain't gonna cancel, right? show off my awesome graph. So, I don't know, how many guys killed the X's? A few guys. How many guys killed the Y's? How many guys aren't quite awake yet? See, you put your hands up, so I don't believe you. If you weren't quite awake yet, you wouldn't put your hand up. Alright, now personally I would kill the X's just because it's a little bit smaller numbers, right? But it really doesn't matter. So if you kill the X's, what did you multiply the first one by? By 3. And the second one?
2.
By 2. So then I get,
6x.
yeah, so this will be 6x minus
15.
15y equals,
Negative.
the biggest mistake is to forget to multiply this poor dude. Everybody, you can't multiply one side and not the other side.
Negative.
And then twice this one, negative 6x
4.
plus 4y, negative 8. Now here's the, see what happens here? Did Jeff make a problem that works?
Negative 11.
Ooh! You guys alright?
Yes.
Yes? Alright. Now, if you solve for x first, when you plug it back in, did you get this for y? See, it doesn't matter which letter you get first. You're going to end up at the same place. So if y is 1, how do I get x? Plug it in so I can use the first one maybe. 2x minus 5 times y, but y is 1. You can add 5, 2x is 4x is 2, bam! So then the answer is 2, 1. I like it. All right. If you don't put the point down, you're not wrong. I'm just saying it's a little tiny bit better because it's representative of the idea. It's where the lines would meet. Is this coming back to you guys? Does this seem familiar? Real quick, will you always have to multiply both equations by something? No, if this would have been a 10, I would have just had to double the first equation. I would have left the second equation alone. Just like LCD. That's why I love it. It's exactly the same idea as LCD. You try to make them match. I like it. What? I never noticed how bright that thing is. Jesus. Alright, I can. I've almost got sight. Alright, here we go. Oh, yeah, okay. I love the infamous, he knows there are 62 legs. I gotta say, that's one of my favorite phrases. It's like the guy that puts money in the bank and forgot how much money he put in the bank. I'm like, what a problem to have. Holy shit. I know exactly how little money I have. Can you figure out how much if you made this much interest? I'm like, who is this person? So here's a farmer that knows he's got 62 legs amongst all his animals. Don't judge, I mean, gets bored out there, I don't know. Just knows how many legs he got. Now you do have to realize something about ducks and cows. How many legs does a duck have? 2. 2 legs per duck. How many legs does a cow have? 4. Okay, good. We're assuming that they're all healthy, have had no problems, were born with all their limbs. That's a big assumption to make, but that's what we're going to assume. If it wasn't true, they would have to tell me. Oh yeah, that one cow has 3 legs. You guys with me? Okay. Now, the word problems that go along with systems of equations, they actually set up a little bit easier once you realize what you're looking for. I am looking for 2 situations. So, what are my 2 situations? Not the ducks and cows. That's what's involved in the situations. What are my 2 situations involving them? The 62 legs I already pointed out. One equation is going to be all about legs. And the other equation is going to be all about animals. So what are my variables? What is it that I don't know? So the number of cows, what do you want to call that? C. I like that even better. And I can use, and if you want to use X, it don't matter where they. You could use freaking W for whatever, just to say cow. Whoa. What about, by the way, it's number of cows, right? I didn't spell cows like with a K. What about number of ducks?
Why?
I love it. You use Y or D, doesn't matter. They're just placeholders, right? There's nothing special about X and Y. So what's one equation I can set up?
C plus D equal 24.
Yeah, the number of cows plus the number of ducks has to be 24 because that's how many freaking animals he has out there roaming around on their legs. Now the other equation has to be all about legs. So it can't be C plus D because for every cow, how many legs do I get? Yeah, I get 4 for every cow
Plus 2D.
plus 2 for every duck is supposed to make 62 legs. So what people do is they mix these numbers up or whatever. You have to think, what is the physical meaning behind the thing I'm writing down? It actually has to make physical sense. Math isn't all by itself. Math is intimately a part of everyday life. You guys don't believe me, but that's okay because I know it's true. So now you can solve this whatever way you like. If you know substitution and you like that better, you can solve it with substitution. I'm going to do elimination. You guys notice you can divide this by 2, but I'm not going to just because we normally don't see that. So what can I multiply the first one by so something cancels?
Negative 2.
Yeah, I could kill the D's by multiplying the first one by negative 2. Now you could also multiply the first one by negative 4, but in general, pick a smaller number, it's less likely to make a mistake then. So if I multiply this by negative 2, I get negative 2c minus 2d equals
Negative 48.
negative 48. I love it. So these two equations are equivalent. They are the same. Because I did something to both sides, so it's the same. Let me stop there. I see a few concerned faces. Everybody cool with what's happening. So they weren't different signs already, so I had to multiply by a negative. Now, if I add those two together, what happens? Kill the ducks. He's dead. Oh, God. Sorry. I'm in a really weird mood today. I just had Game... Anybody watch Game of Thrones?
Oh my God.
So now in my head, since I had a duck die, I thought Game of Ducks and quack, 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 quack. Yeah. So what do you get with the cows? 2C equals 14. I love it. Now, is everybody cool with what's happening? Everybody get the idea? And this is why I like to relate this to forensic science. If somebody dies, I got all these things I don't know, I start to gather information. So here, if I have 2 things I don't know, I have to have 2 pieces of information to tease it out, to figure out each of them. So if I had 3 things I didn't know, I would need 3 equations. If I had 11 variables, I would need... Oh, we're not going to do that, though, don't worry. We're going to do 3 at most. So C is 7. And how do I get D? I can do this one, that's a nice one. 7 plus D is 24, so D is 17. Now what's wrong if I just stop there? Now don't even write it as a point. This is a word problem. What if you just figured out there are 7 cows, 17 ducks? There. So for a word problem, don't write it as a point. Because there really isn't a cow and a duck axis, and there's these cow-duck hybrids, I don't know. Wahoo. All right, you guys try number 2. It's basically the same problem, believe it or not. It's just not involving legs, it's involving value of money. So try to do number 2. You almost always have one equation that's a total equation. The 2 variables add up to be something. And the other one involves multiplying each one by something, like the legs problem. The number of legs. Here it's going to be value of the coin. Here you go, man. Wait. Give one to him behind you. Oh, there's another one. Wait. There's another person coming. Oh, there's another person. We'll let him come all the way down. Too nice. All right, guys, let me catch up to you. What are my unknowns? Number of dimes. I'm going to use a D for that. Number of nickels. I assume you use an N maybe. Or X and Y. You can always use X and Y. It's just less obvious what they represent then. So the first equation I can write is always the easiest equation, and it doesn't really matter. There are 36 total points. There's my total equation. So I just do
D plus N.
D plus N. 36. Now the other one is going to involve something with each variable. Like the last one was the number of legs per animal. Here's how much money per coin. So here's where you got to be a little careful. What are you going to put on this side? Now, if you do this, if you put 2.90, you better not put frickin' 10 in front of D. You don't get $10 per dime. Don't get excited. So you better put 0.10 in front of your dimes. And nickels. Now, hopefully, somebody out there was kind of clever about this and said, let me write it in terms of cents. You get 10 cents per dime, you get 5 cents per nickel, and how many cents should you end up with? 290. Which is really just equivalent to multiplying everything by 100, right? It's a point that's supposed to be there. All right, you guys with me? You got to be careful, though. I get people that put this on this side and that on that side, and they get like 1.7 dimes. I'm not sure how that happens, Mr. Waller. Well, I don't know how that happened. So be careful. Now you can step back and say, how do you guys want to do this? They want to get rid of somebody? All right, let's do a substitution just to remember how that works. So if I take the first equation and I solve for a letter, what letter? All right, let's solve for n. So I'll subtract d over. So we get n is 36 minus d. Now I know what n is. Well, some of you guys are like, no, you don't, Jeff. And I'm like, yeah, I do right there. It says n is that. I know what n is. So when I go to rewrite the second equation, don't plug it back into itself. You got to get circular logic. You got to get 36 equals 36. It's amazing. You got to plug it in the other dude. You got to use both pieces of information. So I'm going to rewrite the other dude. 10 times d plus 5 times n. What's n?
36 minus D.
Equals 290. That's the substitution method. That's what we call invasion of the body snatchers. You replace this person with something else. You've never seen Invasion of the Body Snatchers. There are several of them to choose from. It's been remade several times. If you don't like horror movies, then I'm sorry. Don't watch them. So then you get 10D plus
180.
180 minus 5D equals 290. So you get 5D equals 110. So you get D equals 22. 22 dimes, so how many nickels? There were 36 total, so there must have been 14 nickels. Yeah. So if you did elimination, you're fine. It doesn't say a method to use, so you can use either one you want. Now before I get too far removed from, I didn't talk about the special cases. Do two lines, so when I solve a system of equations, this is where the two lines meet. Do two lines always meet at a point? No, sometimes they are parallel. So what would the answer to this system of equations be? No solution. The answer is where they meet. They don't meet anywhere. No solution. So we've got to see algebraically what would that look like, right? And another possibility is they meet everywhere. Shit. So what points do they meet at? All the points on that line. That would be the answer. The answer would be all the points on the line. You guys semi with me? So here, do that. Knowing it's a special case. While you guys are doing that, some of you guys already have this handout, so just give it back to you if you already got it. I'll give it to a few of you guys. There it is about 7, so I want to have a color. You got one? You got one? You got one? You don't. So real quick, that handout I gave out is the next topic we'll be going over. But I just want you to have this if you want to try to get to Chapter 9 homework. Guys, the first part of Chapter 9 homework is actually some problems from Chapter 4, the ones we just did. But then eventually they get into 3 unknowns. On the back, some of you guys might know the idea of matrices. What? The matrix, right? Not I know Kung Fu. So what do you guys do here? What happens? What are you going to do to the first one? Multiply by -2. I like it. So then you get -6x. Okay, plus 2y. -2. When you add these together, what happens? 0 equals 3. And then you're like, I've discovered something, Jeff. I say, no, you didn't. What does this mean? The answer is when these are true. When this is true, the equations are true. Well, when is this true? Never, so this is... So that means that these, do you guys notice how these are the same, just this is twice that one, but they have different y-intercepts. So they are parallel. If I would have made this number 2, then it would have been 0 equals 0. They would have been on top of each other. That would have been all the points on the line. So there could be one answer, no answers, or infinitely many answers. All right, I think that's enough for today. So we'll get into the new stuff tomorrow.